Physics, topic by topic, looking at GCSE Physics. We're going to look at density. Density, this idea of how much something sort of weighs compared with something else. When I pick up something, some objects appear much heavier than others for the same sort of volume, and that's this idea of density. And we're going to look at this a little bit more detail, really, about how molecules work and how they all interact with one another, and we'll see how we get on and what we can do. So what is density? Well, density simply here equals the mass of something divided by the volume. The important bit here, I suppose, is not really whether we're talking about mass or weight. This one's one that always causes confusion. Simply, if I think of the mass of something remains constant, whereas its weight may vary. So we know that weight is simply going to be mass times the force of gravity. And so if I'm on the moon, then the weight is going to be less than on Earth. If I'm in 0G, this is going to be 0, so the weight will be 0, but the mass will still be the same. So we've got an easy problem to try and solve. We're going to work out now the density of several different substances, and all we need to do is work out what their volume is. To work this out, it's relatively simple. We're going to have a simple table, and we're going to have our substance, and let's take one of these substances, and I'm going to grab hold of a small cube of copper, and this is going to have a length, it's going to have a width, it's going to have a height. That's going to give me a volume when I put that together, and we're going to get then the mass, which we can weigh, and once we've done that, we can work out the density. So there's my full table. Hit a little problem there. Let's turn my ruler around. It'll move now. Now, if we're going to try and work this out, then let's just take our substance. We've got here copper, and I've got to measure the length. Well, the obvious thing is to get my ruler out and try and measure it, and that says, well, this is nearly 2 centimeters. Not good enough. What I'm going to need is something that's a little bit more accurate, and what I'm going to use for this is one of these. This is a Vernier Caliper, and we'll switch it on, we'll make sure it's shut, and then we'll zero it. So now if I open this and I put it either side of my copper, I can now see this is 19.94. Let's record that. So that's 19.94. We'll do the other measurement, the width. This is 19.96, 95, 96, let's see. 19.97. So I've measured these two faces, this one and this one, and now we're going to measure this face here and this one. .31. This is all in millimeters. So let's just put that out of the way. Now I've got my piece of copper. We want to measure this in something sensible. Now, many times when we measure density, we actually measure density here in kilograms per meter cubed, but we can just as easily measure this in grams per centimeter cube. And I think we're going to try and do that one now, because it's going to be significantly easier to do this than to do anything else. So I want to make sure my values for my mass are going to be in grams, and for my items here, this is going to be 1.994, this is going to be 1.997, and this is going to be 2.031 centimeters. They were millimeters, these are centimeters. This is going to give me our volume. So let's call up my calculator and let's see if we can multiply these numbers together to see if we can get something to work. So let's put in my numbers, which are going to be here 1.994 times 1.997 times 2.031, and that's going to give me a volume of 8.087. And I've rounded it there. I could have left it with 4 if I wanted to. Now what we need to do is work out the mass and the density, and to do that let's go over and set this up. So what we've got now is we've got my copper, and what I'm going to do is I'm going to switch on the top pound balance. And let's measure this piece of copper. .07. So there's our piece of copper. Let's go and work out the density for this. Have a look at another one. There was copper. Actually, I might look at a couple. I've got here a small piece of aluminium, and we'll have a look at the aluminium. And then I've got another piece here which is lead. Paul's just trying to focus on it. Not wanting to. There we are. A piece of lead. They're approximately the same size, but we'll have a look and see what we can do with them. So let's measure then the aluminium. So I'm going to record what we're doing. Aluminium. Let's switch on my Vernier Caliper. I'm going to zero it, and then let's measure the width, and this is 2.022. 2.0. I'm happier with a bit more. 0.233. 2.033. We'll measure it the other direction. 2.011. Trying to get it happy where it wants to go right through. Better. 2.023. And finally I'm going to do the height, and this one 2.030. Now let's take the mass. To change its mind a little bit. 21.66. I'm going to measure my lead here now, and then we'll do the calculation. So my lead, I'm going to get my width. Here we are, 2.029. Go the other way, 1.988, and we'll measure our height, 2.033, and let's measure the mass. 87.13. So having done that, let's now we'll have a look at those figures and see what we can do with them. So my aluminium, first of all, I want to work out what those values are. So put the Vernier Caliper away, and let's now multiply these three numbers together and see what we get. So going to our calculator, then we've got 2.033 times 2.023 times 2.030, and that's going to give me 8.34. 89. It's going to be mass divided by volume. My mass we've got here is 21.66. So let's go back to the calculator, and we've got 21.66 divided by my answer, which gives us here a density of 2.594 grams per centimetre cubed. And then finally let's do the lead, and we'll work out what lead was. So we'll multiply these up, and we've got 2.029 times 1.988 times 2.033, and that gives me 8.200, etc. Let's do the calculation. So we're going to take our mass, which is 87.13, and we're going to divide that by my answer, and that's going to give me a density here of 10.63 grams per centimetre cubed. So quite easily I've worked out the mass, volume, and therefore the density of several blocks of metal, and that was really quite easy. What happens if we want to work out the density of a liquid? This is going to be a little bit more difficult, but let's have a go and see if we can do this. So I've got a couple of liquids that we can try out and see what happens. Now, let's have a look at some liquids. The problem with liquids is trying to work out the volume of them, and what I need to do is work out some of these volumes. Now, I've got several liquids here I can play with. I've got some honey, I might try that. I've got some sunflower oil. I've got some glycerol. I've also got here some metal, and we're going to try, this is gallium, so we'll try some of that. So we'll try a couple of those and see what we're going to do. Now, what I want to do with this to try and get it to work is we've got to measure what these volumes are going to be, and the volume I'm going to measure is in something like one of these. So if I take this, my measuring cylinder, and I know what its mass is, we can then press the tare button. So now it's got 0 mass according to the machine. We put in a known amount of liquid, which I can read on here, and I can get the mass. So we can get the mass and the volume. So for this one we're going to draw up a different style of sheet, because what we want for this one is the substance, I want its volume, we want its mass, and then of course we can work out its density. So a lot easier to work this one out. So let's start with the one that probably is the more exciting to try and do, and that is we're going to try and work out gallium. So what I've got with the gallium, I've got it floating here in some water in a petri dish, so it's not coming into contact, and we've got some hot water in the petri dish, and the idea here is just to get this gallium warm enough so that it's not going to sort of freeze on me. And what I want to then do with this gallium, it's not that hot, you can see I can touch this quite happily. I've got some gallium in here, and I want to pour some of that gallium into this simple measuring cylinder. Now I've got a problem, and the problem I've got is it's not going to pour very well. So what I'm going to do is I'm going to use a pipette to try and get this in. This does come with its little problem about trying to get the stuff in the pipette and working. So what I've got is I've got a pipette with a much shorter spout on it. You can probably see this one is much shorter, and hopefully that will mean I can pull up the gallium easier. Alright, so let's have a go. Try and get a little bit more. I've got just a tiny bit on the side. It's causing me a bit of grief. But that's about the best I can do. So I've got here a mass of 42.54. The volume here I've got 5, 6, 7 centimetre cubed. It's about the best I can do. I can't get a more accurate value for this because of the different measuring cylinders that I can use. So we've got the density and we've got the volume. I'm going to pour this back in, and it goes in really well, apart from all the gallium that I've got stuck in here. And to try and get that out, I've got to now, because it's solidifying, make sure that it stays warm. So what I'm going to do with this is I'm just going to put it over the side there, and a bit later I will start the problem of trying to clean that out. That was gallium, and we'll work that out on the calculator in a minute. An obvious one that we could try is water, but we're going to try before that sunflower oil. And I've got another measuring cylinder here, slightly lighter than the other one, and I've got my balance zeroed. We're going to try sunflower oil. So we're going to put a known volume of sunflower oil in here, and judging by how good my pouring skills are, what I'm going to do is I'm just going to get a beaker out, and I'm going to pour the sunflower into the beaker and then the beaker into the measuring cylinder. It's going to be easier to do. So I've got a small beaker here, and let's pour some sunflower oil in there. Then I've got more control over pouring it. As you see, I managed to spill a drop already. Okay, let's see if I can pour in here a known amount of sunflower oil. as good as I can get that. That's about 10.5 mils, as accurately as I can get it. So volume 10.5 centimetre cubed, and my mass here is 9.42 grams. So there's my sunflower oil. We'll do one more, and this time we're going to do an easy one. We're going to do some water. So I've put my measuring cylinder on, and we're going to put a known amount of water in here, and this will give me an idea of how accurately I can do it. Now a steadier hand required. Too much. No, just about. I was worried I was going to go over, but I haven't. That was pure luck. That's 20. Near enough. So water, I've put in 20 centimetre cubed, and I've got a mass of 19.95. So we've done water, we've done oil, and we've done gallium. So let's go and do the calculations. So here are my figures, and what we're going to do is going to try and work out, first of all, gallium. Again, this is going to the mass divided by the volume. So let's go over to the calculator, and we're going to put in the mass, which is here 42.54, and we're going to divide that by, as best I could, it was 7, and that's going to give me a density of 6.0. Working out the next one, which is sunflower oil, we've got the mass here, which is 9.42, and we're going to divide that by its volume, which was 10.5, as best I could manage, and that's going to give us a density of 0.897. And then water, I've got my mass, which is 19.95, and I'm going to divide that by my volume, which is 20, and that's going to give me 0.9975. And all these are grams per centimetre cubed. Something surprising then as we go through here. Water, it should be 1, and that's pretty damn close to 1 for experimental accuracy here, especially considering how accurate my glassware is. The sunflower oil is and has a lower density than water, which is why the oil will float on the water. the density of gallium being 6, we can see is somewhere between aluminium and copper, but less than lead, less than copper. So it is of the order that we would expect. So we've measured here the density of a solid object, we've measured the density of a liquid. But let's see if we can work out now how to work out the density of an irregular object. And this sometimes comes in as a little bit of a puzzle for people to do. So let's go and try this one and see if we can get this to work. So we've got my top pan balance, and I have got an irregular shaped object. Here we are, it's a piece of blue tack, and my piece of blue tack is not a nice shape. There is no way that I can try to measure this blue tack, even to try and hazard a guess what size it's going to be. So first of all, let's take my unknown object. This is an irregular object. The irregular object, we've got a mass for it, and that is going to be 5.83. And now what I want to do is I want to work out its volume. How am I going to do that? Well, what I'm going to do is I'm going to take here a measuring cylinder, and I'm going to put my blue tack in there. What we're going to do with this is I'll move the top pan balance out of the way. I'll do that by switching it off first. Right, let's move that one out of the way. And what we're going to do is I'm going to put a known amount of water in here, and I want to make sure that it's going to cover the top. So let's just put in a known amount of water, and I've put in 20 centimetre cubed of water. Let's put in my piece of blue tack. My water level now has gone up, and this is now at 21, 22. I'm going to get my eye down at the right level to read it off. About 22 points. Well, it's definitely 22.5. It might be a bit more, but my measuring cylinder is only accurate here to about 1 mil, so this is going to be about 22, we'll call it 22.5, 22.5, and we've now got the volume. Back to the calculator. You can work out what's going on here. So there are my values. My density here is going to be the mass over the volume, which is going to be my 5.83 divided by my 22.5, and let's just put them into the calculator quickly. So I've got my 5.83, my usual problem of running out of space, divided by 22.5, and that gives me a density here of about 0.25. Now I know that's wrong. how do I know that that's wrong? Well, if it's got a density of 1, then basically it should be the same as water. If it's a density more than 1, then it should sink. And if it's a density of less than 1, it will float. And that says this subject should float. And obviously not. So my experiment's gone wrong. I haven't actually got a good enough volume there to work out. Well, it's live, experiments go wrong, so there's the theory. The practice didn't seem to be as good as the theory. So that's taken us through looking at density and working out what we can do. I want to finish off now by having a look at the states of matter. I want to look at then this idea of what we call the kinetic theory of matter, and what we're going to do is have a little look at an experiment to try and show what's going on. Right, we'll have a quick tidy of bits and pieces, and I'm going to bring in another piece of equipment here. Now, this is a vibrator. It's just a loudspeaker with an eccentric motor, basically just a loudspeaker. It's going to vibrate. It's going to push this little plate up and down, and when I put the electricity on, we're going to get a small amount of vibration, and if I look down this tube I can see what's going on. Now what I'm going to do is I'm going to get Paul to bring the camera in so we can have a look and see what's going on to these actual molecules, because trying to look with this camera going down here you can't see really what's going on. So what we're going to do is I'll change the camera. Paul's just going to set this up, and so you can see what he's doing I'm just going to zoom out. Yeah, press the wrong button. So what he's going to do is going to try and put a camera over the top so we can see what's going on. And let's have a look at Paul's view. I expected that to work and it didn't. There. Right, so Paul's just going to try and focus in as best he can, and for handheld this is pretty difficult. There we are, we can see these things being vibrating, and you can see they're just moving. They're not really doing anything exciting, they're just doing something. The molecules at the edge are vibrating more and moving around. That's because I haven't got enough beads at the bottom there. But the ones that are in the centre are just staying there. Now let's increase the heat. And this is a liquid. Paul's got to try and hold the camera away from the tube just so he doesn't get too caught up. And we can see that all the molecules are moving around, but they're still touching one another. And this is the state of a liquid. Liquid then, all the molecules are moving around, but they're not necessarily sort of letting go of one another. Now we're going to have a look at a gas, and Paul can't see this one from the top. He's going to have to look at the side now. And let's ramp up here. And if we look at this area where my finger is, we can see just a few of these little balls moving. And that's a gas. That simulates a gas. There's not much in there. We're just looking at where my fingers are. And you see the old molecule popping through here at high speed. So there we've had a look at this idea of this little tube, a simple plate here, little beads on there, and they're vibrating. Either they vibrate so that basically they just touch one another, they vibrate more and start moving around, there's a liquid, and if they're jumping up to this sort of distance up here, then this signifies that they're sort of like a gas. It gives an idea of how these things are set up. So we've got this idea of the kinetic theory of matter. We've got basically either molecules that are basically next to one another, and these molecules are simply vibrating, and I'll show you a model of that to give you an idea of what I mean by these molecules vibrating. So this is our solid. Then in a liquid they're able to sort of move over one another in all directions, but as they move over one another in all directions, then they're still touching one another. And then finally we've got a gas, and this is where you might have one molecule zipping past, maybe another one going in another direction at high speed. Solids, liquids and gases. What we'll do is have a look at what I mean by a solid vibrating, and we'll have a look at a picture of this. What we've got here is a molecule, and it's a molecule something like salt, and if I take this and we vibrate it, then the molecules still are staying where they are. They're still in the same physical positions, but they are vibrating around. One of them's come off. So we get this sort of vibration of the molecules moving, not still at all, and as they get hotter they move around more violently, and as they get colder they move around less violently. What is heat? Heat is simply the movement of these molecules. So here gives us an idea of what simple vibration in a solid looks like. and irregular shaped objects, and don't rely on me to do that one. Although it worked quite well for Archimedes. He didn't manage to lose his head when he had to work out the king's crown and work out that. And he did that simply by stepping into a bath of water which was full, and it overflowed, and he worked out how to do it. We could have done this better with just measuring the volume taken out of something with a different type of piece of apparatus. I thought that was going to work okay. I was wrong. And then we can work out then the next one, which is the different changes of state, which we've met here, and this idea of the different states and the kinetic theory of matter, and the fact that when we try and do some of these things, that matter is not lost. When we do some of these things, we do not lose matter. There is a conservation of mass, just as well, because nothing disappears. We just want everything to stay where it is. So, I hope you found that useful. Thanks for watching. If you found it useful, then please remember to subscribe, and I'll see you next time, next week, in physics topic by topic. And what we'll have a look at is trying to do the changes of state. Until then, take care, stay safe. Bye bye.